Okay, now students, let us solve one more example on Gauss divergence theorem. See the problem. Use Gauss divergence theorem for f bar is equal to x square minus yzi plus y square minus 2xj taken over the rectangular parallelepiped x in between 0 and a, y in between 0 and b, and z in between 0 and c. Okay. Now parallelepiped looks like a cube, only the length, height and breadth will be different here. So what will happen here? This is a parallelepiped drawn. See how to draw it. It covers all three planes, right? Now what is this I? This is unit normal vector along x or unit vector along x axis. J is unit vector along y axis and k is unit vector along z axis. So this I is also the unit normal vector of yz plane, j is the unit normal vector of xz plane, and k is the unit normal vector of xy plane, that we have seen already. Now to solve this integral, okay, what we are going to do is we are going to write the Gauss divergence theorem first. It is double integral f bar dot n cap ds is equal to triple integral divergence of f bar dot dv. This is the volume integral. As I told you, Gauss divergence theorem is relation between surface integral and volume integral, right? Now we are going to simplify this like the last problem. First find out divergence of f bar. Divergence means what, students? It is a dot product, right? Del dot f bar. Del is the operator I dou by dou x plus j dou by dou y plus k dou by dou z dot f bar. F bar is already given in the problem, students, isn't it? So this f bar is taken in this bracket, right? Now as you know, I dot I is 1 and dou by dou x of x square minus, what is this? X square minus yz, right? And what it is? It is just with respect to x. Y square z it is. So derivative of y square z will be 0 with respect to x, right? And derivative of x square is only 2x. Then dou by dou y of the middle term will be 2y. Derivative of 2x will be 0. And dou by dou z of this will be what? 2z. Derivative of xy will be 0 with respect to z. And I dot I, j dot j, k dot k is 1. All other terms will vanish. So you are getting 2x plus 2y plus 2z. 2 is taken common. Now once you get the divergence of f bar, we are coming to the whole triple integration. Now when you write it in the form of a triple integration, immediately replace dv by dx dy dz, right? Divergence of f bar is substituted here, which you got in the previous step. Now think about the limits. Here limits are given in the problem, students. What are the limits for z, c? Limits for z are from 0 to c. Limits for y are from 0 to b, and limits for x are from 0 to a. So limits are given here 0 to c, 0 to b and 0 to a. So now as in the previous problem, we have reached to the triple integration problem, right? Now how to solve this triple integration problem? As usual, first integrate with respect to z, right? 2 is taken common out, constant. Integral of x with respect to z is xz. Integral of y is yz. Integral of z square is z square by 2. Put limits 0 and c. So wherever there is z, I am putting c first, and wherever there is z, I am putting 0. So second bracket for the lower limit will be 0, and you are getting this, correct? Now the next integral will be with respect to y, okay? Derivative of cx with respect to y is cxy. Then this is cy square by 2. C square by 2 constant. Integral of dy is y. And what are the limits now? 0 to b. Now replace y by upper limit b first and replace y by lower limit 0. Okay, so you are getting this. Now one more integral is remaining, that is with respect to x. So normal integration is done here. Replaced x by upper limit and then by lower limit. And then when you combine all these terms, see denominator is 2, right? So 2 is getting cancelled, and a square bc plus ab square plus abc square. And from these three terms, abc is common. So what remains is a plus b plus c. So this is the answer for surface integral. Thank you.